Hello. It says we've been live for a while. Hopefully not too live. Hi, everyone. So we welcome to a Golioth live stream with some special guests here. We have not done a hardware live stream in, I think Dan and I were looking, it was October of 24. So it's been a solid 4 months. And many things have happened since then. But most of all, our friends have reached out and we've started talking about some other hardware things. So why don't we do some quick intros? I'll start and then Dan can go and then Pete and then Chris, and then we'll start around here. As a reminder, I'm Chris Gamble. I'm head of hardware and developer relations at Golioth. And usually I'm the one tinkering in KiCad as we do these videos, as I will possibly be doing today as well. Go ahead, Dan.
Cool. I'm Dan. I'm CTO here at Golioth. I try to dabble in more areas than is probably good for me. But Chris sometimes lets me push the buttons on the hardware too.
Good for everyone. Good for everyone.
Cool. I'm Pete Staples, CEO and co-founder of Blue Clover Devices. And we work on testing. We're streamlining in-circuit testing, and glad to be involved earlier in the design so that we can have smoother tests down the road.
And I'm Chris Denny from Worthington Assembly. I'm the one that does the dirty work of putting all this stuff together, making all the solder joints happen, and just happy to participate.
Participate from where, Chris? I think you were off camera before when you explaining where you were.
In the background.
I'm in Honolulu, Hawaii. Yeah.
Okay.
Supposed to be on vacation, but Chris makes the call, and here I am.
Well, that's wonderful, but hopefully it's not. I mean, hopefully this is a vacation for people watching and for you, Chris. And
that's right. That's right. That's the honest truth.
Every day working on hardware is its own little slice of vacation. So this actually all started because Pete reached out. So talking about maybe respinning some hardware for the PLT, their product that they work on at Blue Clover, and it's a piece of test equipment. Sorry, it's a piece of electronics that they show as part of the showcasing the test and test infrastructure around it. And then I had said, well, and Dan and I were talking to Pete, and I said, well, we have all this open source hardware that I love talking about. Maybe we could talk about it a little bit on camera here and talk about some of the requirements that would be for a next generation type thing. And then I will take those and, probably just mold them to my own, bend them to my will, I'm sure. But, we'll talk about them here. Pete, why don't you talk a little bit about the thought, though, around, going a little broader than just making your own board, right?
Yeah, we all have things that we do and we need to show it in some way, and it always relies on there to be a device, and we all have customers, but we can't easily take a customer's board and say, oh, look at this cool stuff they did, look at this dumb boneheaded move. Like, it's just not appropriate. So you have to have a sample, and we have to have a sample, you have to have a sample, Chris has to have a sample. Turns out all the component makers have to have samples. And so it's kind of been an epiphany that, hey, we don't all have to work in isolation. And so I reached out to you, Chris, first, and turned out, yeah, you had something a lot like what we were envisioning already. And I think that can be a great foundation, and we'll just invite more people to the party and see where it leads.
If you want boneheaded hardware, you've come to the right place. Let me tell you. But I think you are right. I mean, like, having a common context. I mean, one thing that we've done. So we're talking about the Aludel Elixir here, and really just the Aludel platform. We open sourced that back in June or July of last year. And it's really because, hardware is not our core business at Golioth. We do a lot of hardware and we showcase IoT things on hardware, but ultimately we want to enable people. And so that's why we open source things and want to showcase the firmware, the hardware, and everything, because ultimately the cloud side of IoT is what Golioth does well. That's where Dan is a absolute wizard. And ultimately that's, this is a platform for us to build on top of. And so it would be great if other people can build on top of it as well. So what are the things that, both Chris and Pete, what are the things that you're trying to kind of showcase normally? Maybe give a quick overview of your, say you're at a trade show, what are the things that you're trying to talk about where you might want to be showing a customer product, but you don't have that kind of on hand to play with?
Pete, if you want to go first, I can jump in after.
Okay, sure. So you're always designing a board to do something, and people in manufacturing always complain, well, they don't do DFM. They don't think about how it's going to get made. And then people doing testing, same thing. No DFT, no design for tests is entered in. And so I guess representing test, I'll just say, think about how this board's going to get tested on the line. AOI is fairly accommodating because that's a camera-based inspection. You don't have to think a lot ahead of time about how you're going to facilitate that. But bed of nails fixtures, you really do. You have to have things for those nails to interact with. And so I guess thinking about the test points, even though they don't cost anything, that's an advantage. But sometimes people don't leave space for them. And that's one of our recommendations in the design phase. Is I think about how you're going to get signals in and out of this board and give us a little pad to touch.
Got it. So it's like basically having like a use case of kind of an A/B. Like A is high density, but it didn't have test pads, and wouldn't it have been great if instead it had this simple set of additional requirements, and it's really not that much overhead, but look at all the great things you get when you're using something like PLT or just end-of-line testing generally.
Yeah, you don't want just a board, you want a good board, and how do you know? You have to prove it. And so the only way to really prove it is to send the signals in and out that it's going to expect in the wild. And yes, you don't want to waste space, but people sometimes miniaturize to the point where you're kind of cutting off your own foot because you don't have a way to prove it's done properly. You just don't have any evidence that this is going to work.
Yeah, it does kind of sound like the similar kind of things that we think about internally as well. Is like, we have Hello World samples, right? I mean, Dan, we see people doing like, Hello Goliath type samples where it's like talking to the cloud, but that's not ultimately what they're going to be deploying. Like, Dan, what's something that would be a more realistic IoT sample that might be, on the board, on a real piece of hardware, that sort of thing?
Yeah, I think a lot of times the thing that, really two things I'd say is when you're just doing a simple example, a lot of times you're like booting up and doing something and then you're done, which almost no device, especially devices that work with our platform, are doing that. So devices that like go to sleep. And if you're going to go to sleep, right, like that takes more time, right? So it's not quite as simple and straightforward to walk through that kind of scenario. And then also just like the environment that your device is deployed into. So for example, it's a little different than like, Signal IO, but if you have a cellular device, right, like understanding what the network is like in the environment it's going to be deployed in, all of those things are really hard to simulate in just like a Hello World sample. Last one I'd say is like OTA updates. That is, if you have, I was actually talking to a customer this week that they were kind of early on in their product development, but they were looking to get kind of like a beta test out to a lot of customers. And they made the comment, if your OTA is rock solid, then you're good, right? Because like you can keep iterating on your product from that point forward. Yeah. And so, that I think that's one of the most critical things that a lot of times, a Hello World sample might just skip right over.
Right. Hello World, getting the Blinky, that sort of thing. Like if it's just an LED on a board, I'm sure, Chris, that's probably not a great way to showcase the capabilities of a assembly operation, right?
Yeah, it's funny. Pete and I were talking about this last week, and we were trying to, we were talking about the opportunity to do something like this and how exactly we would talk about what design for assembly means, design for manufacturing means. And we always kind of think of it as in a sliding scale, right? So there's like, if you put big chunky 0603s on a board and, nice big gull wing leads, that's bread and butter. Anybody can build those any day with the cheapest equipment imaginable. And then you get more realistic, like people are using 402s, 0201s, and they're starting the EGAs and lead devices. And then it slides all the way down to chip scale packages and 0155s. And then it's like, okay, or you're cramming parts between, I've seen just all kinds of crazy stuff. And I always think about like, okay, we kind of just have to inherit this because we need the design to do what it's intended to do. And a lot of times there's very little wiggle room for assembly. So we have to accommodate whatever the designer needs us to build. But we always like to be proactive as much as possible, especially on the design side, to lend advice and be like, okay, if you do that, there's going to be downstream consequences to the manufacturability of it. And obviously the test as well, as Pete was pointing out. And it's like just having that awareness and having that understanding of the upsides and the downsides of your decision making early on can just, I believe, can help design an ultimately better product.
Yeah, ultimately, yeah. I guess how does that manifest most of the time? Because I have to imagine for both test and assembly, it's like people kind of come to you and they're like, "Well, I'm ready, so just here's my files, go for it." And you're like,
Yes.
"No."
Yes.
You know, that's I'm sure another piece of it is kind of discussing it up front, but it's kind of hard to get to someone, you know, unless you have a time machine, getting to them at 6 months prior, 10 months prior.
Right. Exactly. So that's usually the scenario, right? Somebody comes to us and they say, "It's designed, build it." And I would say probably, to be fair, probably 95% of what people order with us, we just build it. No issues. Like we can build it. There's a lot of great designers out there, and they're doing great work. But that 5% of the time we run into something, we go, look, the way you've designed this is impossible for us to build. Well, not impossible, but like you've designed it in a way that rather than order a $200 stencil, we're going to have to order like a $2,000 stencil. It's going to be chemically etched, and it's going to have all these steps. It's going to have all this weirdness, or we're going to have to use some other technology that is just crazy. And if you made this literally one small change to your footprint, we could just use a standard $200 stencil. So that's the other 5% of the time. And I'm not sure the ultimate goal of what you're trying to achieve here, but I would love to see something. And I would love to be able to throw my input on this, where, as you had mentioned earlier, when you go to a trade show, you want to be able to show somebody like, look, if you design it this way, you're going to be able to make 10,000 of these things in a snap of a finger. If you design it this way, you'll still be able to make it. It's just going to be a lot more expensive and a lot harder, you know, and it's just having that awareness and having that understanding.
Yeah. And that like DFM, I usually, when I think of those kind of like DFM, like early intervention type things, I always think about like my early 3D modeling type stuff where I had no idea what I was doing. And I was like, well, this can be like a 0.5 millimeter thick wall and, no draft. And I'll just send it to like a injection molding place and it'll be fine. And every mechanical engineer is just like screaming and tearing their hair out. Right. And just like, that is not how that works. Right. And
exactly.
The long lead time from like that decision process all the way through to an actual mold getting cut. I think that's probably an even more extreme model, or like harder thing to kind of map out. So you have to have that end knowledge at the beginning and think with that in mind. I think in electronics we have a little bit more leeway, a little bit more like give, but sometimes the application space, so the board we're going to be looking at here is not space constrained. It's kind of a beast, but that's when you are more space constrained, you start to really feel these being designed into a corner and having to kind of just deal with the consequences of it. So,
yeah, tell me about it. Pete and I were just working on we've been building these boards forever, and we wanted to use this board as kind of a internal demonstration to our team about how design for test is done. Now, we design these for assembly, and they're a breeze to assemble. We just blast these things out because we designed them for our factory. But then he goes, well, here's what we need if you were to test these. And we looked at it and we go, oh my God, these are not at all designed for tests. These are an absolute mess. And because it's a relatively small board, we had to make a bunch of changes to try to make it fit in after the fact. And it was just, it's kind of like we had this nice, clean, beautiful design earlier. And now that we've made it designed for test, it's kind of ugly and messy, but it will test now. But it's true. Like if you know what you're doing ahead of time and you walk into it with that knowledge or with that understanding, it would have been so much better. Yeah. Now we're trying to adapt to what we already had.
I mean, as a bit of I'm not a perfectionist in many ways, but like when silkscreen starts getting messed up and I've like put a design in silkscreen and then like I have to put test points in that like mess up my silkscreen. Come on, Pete. What are we even doing here? We're here for art.
I didn't even bring up the labels yet. You're really we're gonna come to blows when I say I need a great big keep out for a label in the board. And
Yeah,
nobody wants to, that's just dead space to the designer. But
that's right. Yeah,
how are you going to identify this board? Like,
totally.
these boards will move around on a production line, and they may have IDs inside of the chips, but you can't see it. And so it's really, that's
What you're
another-
going to do, Pete, is you're going to tell me to print 1/4 inch by 1/4 inch labels and put 97 characters and a QR code, and I'm going to need a $10,000 label printer to make that work.
Yeah, exactly. They have to be completely like resistant to all chemicals for all time.
Exactly.
Right there.
That's it.
Bingo.
That's the one.
Yep.
Yeah.
That's it. Yep.
And you believe me, you think assembling circuit boards is hard. We couldn't believe once we decided to start offering printing labels for customers. I was like, oh, this is way more complicated than I ever expected it to be.
Why?
Yeah.
Well, I thought maybe we could take a look. So, like I said at the beginning, at the top of this, I said, I had offered to Pete the Elixir, and to be completely upfront about it, I already had a thing in mind to rip up parts of that board for greater modularity and things like that. But I thought maybe we could kind of transition into roast my design as it currently is, and then we could use that kind of segue into the discussions of other things. So let me just show what we're working with here, what I was hoping to do, and then you guys can tell me why it's all a terrible idea. And Dan, same on the firmware network side. Don't take my feelings into account here, okay? Just
Chris has thick skin,
never did.
so let's go for it.
Yes, yeah, a lot of calluses from a lot of mean people in the past. But we're doing it live. Why not? Yeah, okay. Let me share a screen here. All right. Let's see if this works. Yes. All right. So just to walk through, this is the Elixir board. It is. I already changed the silkscreen color, the solder mask color, because as you rev your board, you got to change your solder mask color.
Let me stop you right there. Just make it green, for the love of God. Just everything green.
Nope. Not going to do that. Not going to do that. This is.
But I will say
artwork,
there is actually a manufacturability difference between black
AOI
and almost every other color. Not just AOI. It's actually the ratio of how long and skinny you can make solder masks feature. When you get into really tiny components, you can't actually do it with black without some special technology that not a lot of fabs in the world have. There's a few fabs in China that have them. I think there's one in California that can make these really, really tiny slivers. But black does actually make a difference. But don't trust me, you're not.
Don't let that stop me. Yeah. We that was a new record. That was like 2 seconds, Chris. That was like, wow. All right. So anyways, I had just changed the color in KiCad. That's all it took was like click. So I can, if you want, I could change it to blue. I'm not going to do green.
No,
just
no
be
problem.
stubborn.
Just,
okay.
No problem.
Just on this,
it
what
black.
this is though. So this is this is something we've been building for internal reference designs for a long time. It's basically built on top of this this case size. I really like these little flanges on the side here. We mount these into different places, and we have a face plate that goes over top of it as well. So that's a I2C based display that we pass readings up to that has touch and stuff like that. But then ultimately, this board you're seeing here, NRF 9160, ESP32C3, a bunch of auxiliary components. But probably the other key thing here is that it's got a bunch of headers. These are microbus click headers to make it extensible, right? The whole idea behind this one here is that, so again, this form factor, I probably should have a little close up, but this form factor can fit click boards, the things that plug into these headers that are shown on screen here. They can fit into this case, and you can make it a bunch of different things. So that really benefits us because we want to showcase a lot of real world use cases or approximations of them, because these are not end products. They're not waterproof. They're not things that people have to do when they truly are making a end product. But that's kind of the genesis of this. This used to be, so the Aludel is kind of the form factor. This is the Elixir board. We're going to come up with some new alchemical names for these. I've been on ChatGPT coming up with some new names. So we'll reveal those at a later date. And then on the right side here is what's called the DRAM, spelled DRACHM, but said DRAM. Really great name. We have to tell people how to say it each time right there. And this is basically, this is kind of communication core shrunk down to approximately the same size. And the idea here is to make it extensible, so modularizing my own design in order to be able to swap out for, so right now this is the newer version, the NRF 9151 chip, that's cellular module with dual Cortex M33s, and again, the ESP32C3. But the idea being that when we want to switch this out, Zephyr and even ESP-IDF, which are both ecosystems that we support, they are very modular, very possible to have different board definitions, but we could do that at the module level and then drop that onto a carrier board. So the thinking here, and the thing that I told Pete that I was going to do, maybe on a live stream, maybe after the live stream when we discuss this, is basically take the Elixir board, rip up the parts that have been placed on the DRAM, put the DRAM footprint onto this board, and then kind of mold the other peripherals around it that Pete was hoping to see and others might want to see in the future, right? So making a landing board there that ultimately takes the DRAM module and then is kind of interchangeable. All right, let's talk about things that I'm doing wrong first, and then how we might modify it as well. Oh, actually, we have people in the chat as well. We should say hello to them. First off, the contributor to the library here, Helmut Lord from Nordic Semiconductor, who built this library that is currently supplying the 3D model and the footprint for the N9161, which is that's just the 3D model. It's actually a 9151 footprint. And yes, it is a Nordic Lib KiCad part that you see there. And I'm a happy user of that, so you can use that for your designs. Who else is here? Clubman, how you doing? Coming in from Sweden. And I don't know this last one. Bartholomew, I think, maybe. So welcome, everyone. We also have people watching after the fact, and we'll have more feedback, but there is a live chat if you are watching live. All right, other things that are on this board, high voltage input section, that's for, if we're powering it from, I actually found out you can power it from solar cells. As I plugged in a solar cell and it started working. But really that was targeting both PoE, so 48 volts, 12 volts off like a CAN bus. We need, for the click header, there is a 5 volt boost here because we need to actually, when we have it is battery powered as well. So there's a JST 2mm plug here. There is a charging chip. There's a fuel gauge chip. We can charge it off the 5 volts and USB. We can charge it off the 24 volts that might be coming in from an industrial bus. All of those feed in here and charge that battery. But when the battery comes back out, obviously it's a lithium ion battery, so probably nominal 4.2 down to 3.5. We need to be able to boost that back up to 5 volts for the 5 volts that's available on the microbus here, and that is controllable from the microcontroller. External flash, USB to serial, some sensors over here, and then downstream switching, being able to turn off the power rails to different components on the board, because when you're in a low power state, you probably don't want to be feeding even a low quiescent current. Sometimes you want to just turn everything all the way off, including the I2C. So you don't want to have to do all the pin configuration. So we have that switching in here as well. Yeah, some of this stuff is getting pulled onto the DRAM module. So the secure elements on there. Obviously, all the stuff from the 9160 is on there. All of this stuff here is on there. And what was the last thing? The memory, the external flash as well. So actually, a lot of space has been freed up on this form factor to be able to pull. And actually, this module is approximately in this space right here. But we'll have basically kind of a high density module and then a very, very low density kind of landing board for everything else so that we can put stuff onto. That was the thinking there. So maybe we'll start with that. Chris, high density versus low density, and having kind of having that as a duality of manufacturing capabilities. How does that normally play out? Is that good idea, bad idea? Doesn't really matter.
It's sort of like least common denominator. So you can have one high density chip or one high density area on your board, and that's going to dictate the requirements to manufacture that board, period. It just becomes the least common denominator, so to speak. So if it exists, it's going to be the hardest element to build, and it doesn't matter how simple the rest of it is to build. The other
what
thing
about like a castellated breakout like this though? So if the DRAM module is the high density and then it breaks it out to low density like the castellated edges, so then we could potentially have lower cost on the larger board. Is that a large benefit or not?
Yeah, that makes the larger board so much easier to build for sure. Somebody still has to build the high density board, obviously, right?
Totally.
And then that has to be packaged in a way that you can feed it into a pick and place machine, right? They can either put it into trays or they can put it into tape and reel, but it's going to require some post packaging. So from if you're doing this for modularity purposes, you gain that advantage, but it's not advantageous from a manufacturing perspective because of the additional packaging and the reloading and everything that would have to go into making the board. You're paying for 2 boards, you're paying for 2 processes, all that kind of stuff.
Totally.
It's mostly comes down to cost, but from a manufacturability perspective, that's very easy to put on that board.
Got it. What about Pete from the test level as well? That kind of high density, low density, maybe focusing more testing resources onto the high density is probably going to be more important, but then you also have less room for test points and similar.
Yeah, I'm not seeing test points on the castellated module, for example. Oh,
Bam.
Nice. And I was wondering if this is a standard. Did you create the dimensions of this, or
yeah, for better or worse, this is a Chris Gamble original. I talked to so speaking of mechanical constraints, I took this module to a trade show I went to, and I was like talking to RF Shield. I was like, I really thought that eventually if someone wanted to take this kind of form factor, maybe start on a board like this, they then want to just go drop it into a final product. It could make sense to do that sort of thing and really have it as a standardized footprint, but you would probably want to have some shielding on there. And I talked to a RF shielding person, like the can that would go on top of this. They're like, yeah, that shape you made is not possible physically. Oh, okay. Yeah, I probably should have looked at that first. Okay. I swear I've seen something like this. But yeah, because foldy wings, you gotta, channels.
Anything's possible. It depends on how much you want to pay for it, I suppose.
Yeah, right. Tiny welding sparks.
Yeah, I was gonna say little welds.
Well, I like the click headers. That's awesome idea, and that's a really neat ecosystem. And then you have some the QWIIC headers as well. I think on the bottom.
That's right. Over here.
That when I saw that, I was able to just cross out a lot of sensors that I thought should be on the board itself. And I think it is nice if the big board, the carrier, could be inexpensive. And I would tend to, if we're going to make a bunch of these and get them out and just have them available, I would tend to focus there. And so I like the idea of having footprints underneath the module so that there can be a working board with a microcontroller on it, and maybe a radio or two too. And then the module could be a way of extending it, improving it, and keeping it up to date. But you've got some way to make a single board that does something. This lower board was made and it had no chip on it. There's we can't power it up and talk to it and do things other than just it's essentially a switchboard at that point. And if we put a chip on it, we can power it up, load firmware, send UART messages back and forth with it and things like that. That's where those test points become you get more power from them. We always think, so this is our version 2, which is nothing on the bottom, just test points, and then all the parts on top. And Denny probably prefers yours because you don't stick your connector over the edge of the board, so that's a nice touch. We did this just copying the Pi form factor, but I know it's much easier if that doesn't overhang. So I would certainly change that. It looked like your test points are on what I would think of as the top on the left board, and that's okay. The important thing is they're on one side. If you've got, if this is your test big and you have all of your test points on one surface, that one plane, and that's easy to engage with. If you put some on both top and bottom, then you've got to have cables going into the pressure plate. It becomes a much more complex fixture, really balloons the cost of it. And
they're usually bottom up, is that right? So like test points go up and board sits on top.
typically, yeah, you'll set the board in the cassette, and then I don't know if you can see this, but this is the pressure plate that comes down on it. And what we prefer are labels on top, test points on the bottom, so then you can scan, have a little scanner that will scan a barcode or a QR code that identifies which board is being tested. Then you run the test, and then you can print another label with the test result. We use these little PLT tested labels, so then when a person sees it, they know something, because they can see, okay, this was tested, it passed. But there's also information for a computer, so in the code you can also pull up an actual test report, for example, or an actual serial number. And so
I would. Oh, sorry, Pete.
No, go ahead.
I was just going to say, I think the side, I wouldn't get too caught up in like the capital T top, capital B bottom. I think what's critical for Pete is that it be on opposite sides. The label and the test points be opposite sides, whichever side you choose.
Yeah.
And then from a manufacturing perspective, if you were to try to do this testing in line, you would want to make sure that your test points are on the side of the board that will be built first. Because ultimately what ends up happening is you flip that board over to build the opposite side. Now your test points are down. And then as it goes through the assembly line, they're on the correct side for that pressure plate, like you showed. If you were to automate it, but a lot of times you don't automate it. It goes through other processes. You take it out and then you put it into one thing.
Yeah, I think I mean, like, at least speaking with this one, I had thought that we would put test points topside and labels topside, which I realize is not what you said. But the reason being that, like, what you're seeing here, this view is actually what you see in the case. So say you wanted to disassemble and you wanted to see, oh, actually, I wanted to see the serial. Actually, so what I do, it's not shown on this one, but I'll often, when I have a SIM card inserted, so this is a SIM slot over here. This is a eSIM that you can also put in there. I actually cut up the SIM card and put the SIM number physically in here as well. And so I can imagine, this is a battery cover. So on top of the battery cover, I put the SIM number, so that when I'm ultimately, I can always plug in, get the IMSI number, whatever. But really what I want to do is I want to open the case up, be like, oh, look, this is, last 5 digits, 67890.
Could you enlarge your view just so I could see a better perspective of that?
Thank you. Sorry. Actually, you know what? I can do you one better. Let me turn on a close-up cam. Make sure there's nothing sensitive in line here.
Just that secret Apple Car project you were working on, right?
Yeah. Apple loves my huge hardware. Okay, so welcome to this is the Aludel platform as it is shown, and you can we'll go back to that screen, but actually this is the view you're seeing on screen right now. So there's a bunch of buttons at the bottom. This is a 3D printed. Sorry. This is the 3D printed case here, or back panel here. We actually get these cut out so that this part is a swappable plate. This is a swappable plate, and then ultimately this is the battery cover. This is the high voltage input, and sometimes we do the smaller versions of this where we have the high voltage input popping out of the board as well. This is called the loot cover for this smaller form factor. So trying to be as flexible as we can be with these different boards. But ultimately, I open up normally there's a cover on top of here, and I would pull what's called the Extensibility off of here, and then you'd be able to see modules that are in here, things like these clipboards might be installed, and then I want to be able to see the SIM number that I was talking about would be would be here. And similarly, if I pulled the battery cover and the battery itself off, I would imagine that the test points might be, within here, and the labels might be underneath the battery as well. So just from or maybe otherwise visible, but maybe between these headers, in between here, that sort of thing. So it really is kind of an origami project to try and get all this stuff fitting together. But I think that I would probably, if I was to have a fight with Pete about one thing, it'd be like I would want to have test points on this, because ultimately the backside here is already kind of busy. Maybe that's not a big deal. I do wonder about whether these castellated edges are probable as well, and maybe that would actually alleviate.
I was wondering that same exact thing. I was hoping Pete might be able to answer that.
Yeah.
What are the requirements, Pete, for that sort of thing?
Anything's possible. The most common is a 1 millimeter diameter, just a pad. Circular pad is the easiest, but there are all manner of tips on the pro tips that can engage with through-hole legs or gull wings or castellated edges. There's a tip for every surface like that. So it may not be stocked at as many places, but it's possible.
Pete, I was wondering, for like a more modular system like this, and maybe it wouldn't actually be, separate boards even, but I'm curious if in the manufacturing process, there's ever like a kind of like a multi-stage testing setup where, you might test like the DRAM board here individually, what I would think of like, from a software perspective, like unit tests and then integration tests. And if that's the case, like what that process looks like. Also, Chris, we're gonna have to mute you, man. You're
I'm getting all my hardware, and these boards are not. They're all in plastic. I'm sorry.
No, it's all right. It's all right.
It's all for the greater good, I promise.
Yeah, you can. Like our advice is to put some code, some label on every board, and then it wouldn't be any big deal to say, write up a test plan. It's just a script that says scan baseboard, scan module. So you're getting both of those into a test report as a combo, and then run a test, and then print a new label that represents this combined subassembly. And you can think it up and then just write that up, essentially. And it's really good to have that traceability. Many products we encounter just have multiple boards. Maybe they're not, soldered together, but there are many boards that go into a finished product. And it's really nice to scan all those codes off all the boards and then test the integrated product, and then have a serial number that ties them together.
Makes sense.
Okay, Chris has something to show.
Yeah, I found a couple other units here, huh? But yeah, this is what I was talking about here. So when it is a little easier to see here. So again, like
that's a really nice custom label you.
Thank you. Yeah, that's the shape is whatever my scissors made me do that particular day.
You can also print multiple labels. So if it's like, I want the label here, but then I'm going to cover it up with a plate, it's certainly possible to just print duplicates. And then like customers do that all the time. They'll have one that's stuck on the board and another that's kind of like taped to it so it can be put on the enclosure box or something.
Yeah, right. So like having something like on the back here. Oh, there you go. Loaner 2. Yeah. So, all right. What did I do? There we go. Well, any other, front versus back, I think, Pete, you had said maybe it's possible to just kind of fit. I mean, you obviously could fit test points in here. You see there are some test points already on this board.
Yeah.
Some of these are just breakouts and extras here, but that would be additional things that we'd go for.
I think you had a Tag Connect footprint on there, and so those are a way of programming. What I don't know if I have one. I do have one. So like you can connect a flasher to this cable and then plug this in. That's pretty dense. So if you could replicate those pads with larger, more spread out test points,
Those are that's all here. TP 456 is the SWD IO and SWD.
Perfect.
And then this is actually a 10-pin header as well that goes off the edge of the board, because one thing that we found is when we were doing prototyping in past versions, we'd have to disassemble the whole box. Actually, the 10-pin header was on the bottom of the board or bottom of the case. And so at one point, one of our folks ended up just drilling out the bottom of the case so that you could get at it easier. And that was the workaround for the Rev A for sure. Being able to get that stuff going,
So one thing that we could talk about is the connectivity. So Golioth would prefer this device connect to the internet. I feel safe to assume.
Almost every time. Yep.
And our board does not. So we did a demo board with BLE NRF52 on it, and so it could connect somehow through a phone or something, but
NRF52 can connect over thread. You could put open thread on there, and it could connect very well to Golioth, and maybe future things in the future too.
So you mean on the production line, if you just wanted to provision that board, I assume you need some infrastructure as well, not just the board like powering up and then connecting directly.
For the thread case?
Yeah. This example of yours has a cellular radio. So you power it up and it's going to just find tower and find Golioth.
Hear that, cellular people? It just finds the tower. That's how easy it is. No problems.
Just get hyper technical here.
Yeah. No. But you do make a good point that you need some sort of border router to be able to facilitate communication to Golioth, which is then another component to the setup that you have to have. So definitely the complexity would go up. I also think folks are probably just interested, and I mean I'm personally interested actually in cellular connectivity and testing that sort of thing on the line, because obviously a factory. Yeah, go ahead.
Let me speak to that a little bit, because we've done plenty of boards that test with cellular connectivity. You literally, so as a manufacturer, we're in a steel box, right?
Yeah.
Steel box.
Starting off great, Chris.
This is where I was going. Yeah.
And then you've got machines
power them all on at the same time.
All kinds of crazy noise, right?
Mm-hmm.
So we literally have to set up if you're to do cellular, we either need a repeater that comes into the building from an antenna on our roof, or we need to have our test equipment at a window and literally like in the window practically in order to get a cellular signal.
Yeah, that checks out. Have you had like issues where you're just not able to do that? And like what's the workaround? I guess like you can't do anything.
In this one particular case, the workaround was to literally set up an ESD safe environment in my office, and just like I didn't work in my office for a week, and somebody just did all the testing inside my office for a week, because I have a window in my office, right? You normally put the offices by windows in the factory in the middle of the building, right? And that's just what we had to do. So, and the tricky thing was I don't know if this is still the case because I haven't really kept up with it, but at the time, Verizon was on a different technology than AT&T here in the United States, right? They were using
that's a little outdated.
Yeah, okay. I thought it might have been. But at the time, you couldn't. They wanted to test for each type of technology, and we had excellent AT&T service at our factory and meh Verizon service at our factory, and that further complicated things.
Mm-hmm.
Yeah, that's actually why Chris is in Hawaii right now, to get better testing. He brought a bunch of boards with him. He's testing on the Honolulu towers.
That's right.
Well, that's why he's so high up right now too.
I am currently tethered to my iPhone because the hotel
Bingo,
Wi-Fi
there you
gave up
go.
on me.
He's testing cellular. Yeah. Yeah, that is an interesting challenge. One thing I've seen is like powering on a bunch of boards at once, basically overloading towers, things like that. I used to work in MVNO, and like, when you have a bunch of roaming devices trying to connect to a tower, maybe farther away than they really want to be as well. Lots of false positive, false negatives, sort of thing. It's messy. It's messy. So it's an interesting challenge.
Yeah, and I mean, even obviously cellular has lots of challenges, but like, let's say you have a Wi-Fi device, you're in a factory, you've got to get credentials for that network on the device somehow, and you probably don't want those credentials on the device once it leaves the factory. So, plenty of complications there as well.
Yeah, and we're set up for that now. So we've gone down this road with cellular testing. So now we do have a test site in a window, so that way if there is cellular testing, it's done. They don't have to come in my office anymore. And the same thing with Wi-Fi provisioning. We've done it enough now that we know how to do it. We know how to secure it and keep it off of our network, but still give them the access they need and bypass all of our security settings and everything. So eventually, like if you find the right manufacturer, they will be set up for it.
Right. So what I hear is go scan outside the Worthington assembly plant for open Wi-Fi networks, and you get some free internet.
You know what? What's funny?
Restricted internet.
So let me tell you something real quick. We haven't had anybody do that, but we regularly have, like every year or two, we have sketchy people come to our factory asking about our solder dross. And they're like, "Oh yeah, we're here to pick up your solder dross." We're like, "No, you're not. We know the guy who's supposed to pick up our solder dross." There is a whole scheme.
What is the word you're saying?
Solder dross.
Oh, like the skim off the top? Like, is it just like copper?
Correct. It's silver, tin, copper, gold.
Yep.
And when you melt down just a small bucket, like a 2-gallon bucket, if you melt that down, thousands of dollars worth of material in it. Wow. So that's why they just like pretend that they're there for legitimate purposes, and if they get the right guy, they're like, "Oh yeah, here you go.
Here's the trash. Please take it out." Yeah.
Yep.
Wow.
So Pete, in terms of other things that you're interested in showcasing, kind of on the line, obviously we're talking about test points and things like that. Other things that maybe like, kind of end of line. We just did a video about end of line testing and stuff like that. What are some things that you expect people to be testing kind of product wise as well that informed that board that you showed?
Well, one thing we're excited to start doing is USB-C, like actually test the connector. So we have not yet built that into a fixture, but many people do that. And the cassette itself would have a USB-C plug that could go in mechanically and validate that connector, and then it's also a very valuable port in its own right, so we could communicate over USB with the device. So
it sounds like I don't need to do test points anymore if you're using USB-C.
Well, it can do a lot, but
2 test points,
still a lot of advantages to the test points. In fact, I asked Chris Denny about, well, what connector, what's your dream connector on the manufacturing side? And he pulled up a blog post. He's like, happens to be, we have a very specific choice. So we can mine that knowledge for this design. And then I'd like to, figure out how the tester can engage with it.
I was thinking about that, Pete, and I was looking at Chris's design. Chris, could you flip that perspective of your board there and zoom in on the USB on the opposite side? So he's got SMT components right underneath it, right? So
just
you've
one.
got a diode.
Okay,
just one. Because the one that we recommend and we know a lot of our customers really like to use is made by FCI. There's because it's USB-C, there's 2 circuits, right? There's effectively mirrored circuits. And in that one you've chosen, all of the pins are surface mount. And in the one that a lot of customers like to use, one mirror of the circuit is surface mount, the other mirror is through hole. And they like that because, first of all, it gives it a ton of strength, but also it exposes all of the I/O. You can actually access all of the pins if you had to probe each individual one for whatever reason for testing. Whereas that one, the other row of connectors, they're all completely buried, almost like a BGA. underneath that part.
Yep. Yeah.
So
Yeah.
like
So you could either add your own.
could work, but then someone would flip a cable around and then it wouldn't work. And so that's an annoyance, but it's harder to detect with this design because some of the pins, like if one half had a disconnect, it would be tough to pick that up.
Got it. So like just like soldering issues, things like that we're processing, that sort of thing.
Yeah.
Yeah. The other thing I was going to mention is you crammed that right angle switch right up next to the USB-C.
Oh yeah, that's in my GitHub issues right there. That is not a good design. I know that one.
Okay.
The plastics. Yeah.
Dirty little secret about USB-C soldering. All of the soldering is done pin and paste. And so what, excuse me, I'm losing my voice here. I went to a luau last night and I was shouting and screaming.
Sounds like a hard life.
So what we'll do is we'll overprint the solder paste. Like we'll put like these wings of solder paste over the solder mask. And then when it gets into reflow, it'll just slurp in and it'll fill those holes in. But because you have that right angle connector so close to it, we don't have any room. So we might starve the solder joints on the right-hand side of that USB port. We might not be able to get enough solder on there to really fill it the way we want to. The left-hand side will be fine. There's tons of room to add that pin and paste, but the right-hand side is really tight. We're going to struggle with that.
And did I have it right that you really prefer there to be no overhang? Like,
yes and no. Yes and no. USB-C, thankfully, the consortium agreed to not put those nasty flanges on USB-C the way that they had them on micro USB. Do you remember micro USB? You'd have those like little wings, those little flanges to try to catch it. Those were an absolute nightmare to assemble. I hope to God I never see another one of these boards because you have to put special routing, and if you miss it during your panelization, you'd have tens of thousands of dollars worth.
Tell us how you really feel, Chris.
It was the worst. But so these new ones, they're flat. The USB-C is totally flat, so you can have them hang off, you can have them flush, you can have them recess. It's really not that big of a deal. We'll try to notice if they're hanging over the edge, and we'll panelize them sort of like mirrored from each other, right? So we'll have, when we panelize them, we'll have them sticking down this way, and then the other row will have them sticking up that way, and that works out fine. It's a little annoying from a depanelization process, but it's not the worst thing in the world. Let me just put it this way. If you don't have them overhanging, life is good. If you have them overhanging, it's just one little thing we have to think about. We have to prepare for it. It's not the end of the world. It's just like, it's useful for us. I'll tell you what, Chris, if you make sure your silkscreen bleeds over the edge for any component, if you have components that bleed over the edge of your PCB and you export that silkscreen over that edge, that's an immediate signal that we're going to have to be prepared for this. It's when it gets cut off that we're screwed. We have to catch it, or you have to tell us. But if you have that silkscreen, we'll see it right away.
Yeah, I mean, one of the design reasons that I didn't have any overhang, because we did it on previous versions with like the buttons are a little bit over in terms of like this, is because one thing I wanted to do for this case is, so like I said, this side comes off. In terms of like assembling this is designed by yours truly, so not the most mechanically sound, but this has a let me go to my camera here. So this is 3D printed end cap. Like I said, we get these milled out. These boards, these cases are milled out, and then we 3D print these for maximum kind of modularity here. This is the view you're kind of seeing. But one of the thought processes is that, okay, well, say you actually did want to make this watertight at some point, and you didn't want to have, you don't care about the buttons for some reason. Well, you need to be flush so that the wall that's normally here on a full size unit, it just has to not run into that, and that's something we literally ran into. So that's why everything's kind of not overhanging on the side of this board. So
that makes manufacturing easier. I will say that it definitely does. It's not the worst thing in the world if they overhang, but it is easier if they don't.
Yeah. Helmet asked, do you have a part number for that half and half USB-C port? Maybe the blog post too. That'd be a good one.
Is it possible for me to? I'm not
drop it in the chat.
I'll drop it in the private chat because I think the comments I don't have access to because I'm not logged in.
Oh yeah, that's on
and then
YouTube. Yeah.
And then if you can drop it in, that'll work.
Yeah, if we drop it on YouTube, then it'll stay with the video too. So we'll try and do that. Yeah. There we go. Keenan says these are 10 secrets Big USB doesn't want you to know. That's a good one. Keenan's a friend of Goliath as well, the Ribbit Network. And yep. All right. So that's a good.
It's in the private chat there now.
Okay, great. So we'll drop this over in the YouTube. Or maybe Dan, if you could do that, are you okay doing that, Dan?
Yeah.
Oh, wait, actually, you know what? I can do that from the chat here, I think. Let me try that. Comments. Yeah, I can post as Goliath.
Nice. I actually have to drop for another one, but it was good to chat with y'all. Hope y'all have a good rest of the stream here.
Thanks, Dan.
Thanks, Dan. Well, we should end up wrapping up anyways. This has been a good one. Pete, you had some other things kind of on the list of, some of the things that were already I think are on this board that are a good fit. But like you had said, like RGB LED for indication. You had said accelerometer for doing some demonstrations, some other sensors, things like that.
Yeah.
In terms of other things that we might need there.
With the click headers, we may put one sensor on, and I'm asking around the component makers who might be able to compass some sensors to make this club board a little easier to produce. And the other two were the LED, so LED sensing, and is something we do where we can detect the color and brightness, and RGB is nice because then you can check different colors, of course. It might be good to have a green LED that's just cheap and just says this board's powered, and then have another one that's RGB. And the second thing is a push button, or maybe two push buttons. So Evo couldn't join us today, but he said just put a reset button on. You always need a reset button. So
yeah,
we'll have
this one here is reset. This is a user button. So this design came from our friend Jared Wolf. It was the 91 Feather. That was the starter design for this that inspired a lot of this. So both the mode, the user button is just a generic input, useful in a lot of cases. Mode is actually part of the startup. So if you wanted to go into MCU boot mode, that's where that comes from. So those are the three buttons.
Put a solenoid that pushes those, for example, and
cool.
Just verifies the button works, and also verifies whatever is supposed to trigger is indeed triggering.
Got it. Yeah, that is tough. The kind of the physical input. Actually, one thing that I was going to ask you about was the switch as well. Does that matter for the connection? Like this on-off switch and stuff like that. Does that impact things?
It does. So. If you could get rid of it, that'd be awesome. I don't know if that's possible.
I cannot. That is, I won't get rid of a physical switch. I'm sorry about that, but soft switches are not for me. But I mean, we could potentially. Yeah, go ahead.
I was going to say, I think Tesla's famous for saying the best part is no part. I think that's what Pete is saying. The best part is no part.
Yeah.
Get rid of it.
This is not a physical connection there from like the power. So this is a switching circuit that pulls down on a MOSFET, but so it's possible to trigger that, I guess, externally. Maybe we could expose that pin so it could be triggered externally. But ultimately,
things that require an operator to do something tricky is part of what we're trying to eliminate. And we put a potentiometer on our V2 demo board with the thought that, this would be cool. Then we can make a board that passes tests, and then we can adjust it and then have it fail tests.
Yep.
But we've come to regret that, because when you look at it, you don't know which it's going to be. We think it's better for our needs to have good boards and bad boards, not boards that can go either way. And another problem was then when during assembly, we didn't know what position it was going to be in at the time of assembly. And so then we had to adjust the tests based on, oh yeah, well then when they ship, they're screwed this way, and then
Oh, I see.
you don't want to tell everyone to have to, get out the screwdriver and tune the board. And so we're trying to eliminate any kind of hand tuning, hand setting, dip switches, all those kinds of things are tend to slow things down in our experience.
I'm not sure when you
just
plan
wanted
on
to
wrapping
quickly
up, Chris.
soon. I had two things. One, I wanted to just show, this is just the lighting.
Okay, and I have one thing before we wrap up, so go ahead.
Okay, and then after you then as well, Helmut has a comment here as well I'd like to bring up real quick. But this is just generic power sequencing, stuff like that. These are not great for super low power, because obviously you'd be burning this power no matter what when it's on, and you don't necessarily want that. So probably switching these to probably more soft controlled IOs instead of just being tied to the rails, stuff like that. So
Yeah,
which is more complex, unfortunately. But when you want to go into a super low power mode, you definitely want to be able to turn those off. So that's one consideration there. The USB, when USB is plugged in, it's kind of quote unquote unlimited power. So I don't mind having the LEDs on. Yeah, exactly. The LEDs on then. So, all right. What was yours, Chris?
Went to unmute myself and turned off my camera. So you have a perfect view right now of a personal pet peeve that every manufacturer has.
Cutouts.
Cutouts. That's the PCB guy's problem, not the assembly guy's problem. The through-hole pins for that JST connector, you have some very small surface mount devices right next to them. We cannot automate the soldering of that. That would have to be hand soldered. So my rule of thumb, and this isn't exactly perfect because it's kind of a squishy process, honestly, the through-hole soldering, is about 3 millimeters of clearance around any through-hole components. If you can, the edge of pad to edge of pad, if you can leave about 3 millimeters of clearance around them.
So from here to this or anything else, right? Obviously, these are
exactly.
But this is actually, this is the most complex part on the board as well. So this is the BGA, that one of the only
that
fuel
looks
gauges
far
that
enough
was
away.
Supported. Okay. It was one of the only fuel gauges supported in Zephyr at the time. So that's why we chose it. And but ultimately that's actually driving a lot of the stencil requirements like you talked about earlier, Chris.
Yep. It's R72, R71, and C6. If you were to bump those away, we could automate the soldering of those JST components all day. But if you don't, we're gonna have to hand solder them. Yeah.
Got it. That's good. Yeah, I can add a keep out on the thing.
And if you can't get a full 3 millimeters, just get as much as you can. That's fine.
Okay. Helmut brought this up as well. I thought that was interesting as well. Adding an onboard debugger. So on Helmut's design, the Royal Blue, I believe. It's the NRF54L15 dev board that's, I believe, crowdfunding soon or now. It has an NRF52833 on board, which is interesting, maybe a little ironic, because that's actually the part that Pete has on that dev board, I believe, right?
Yeah.
Yeah. So
we would upgrade it to 840 or something with USB another time.
Yeah. Yeah, I mean, having a debugger on board, if you can bear the cost, for sure, right? I mean, like, even just this one is a CP2102, and usually the debuggers have, built-in USB to serial as well. So yeah, I'll definitely take a look at that. That's an interesting point, because this is a Scilabs part. They're not cheap, unfortunately. They're kind of, especially in low volume, they're getting the hobbyist pricing in low volumes, but you could start to get higher volumes, you start to finally get some breaks. But yeah, that is an interesting point, and I will definitely consider that. What do you guys' take for, like, do you see onboard debuggers in products often? I mean, I think from a security vulnerability standpoint, that maybe not as having more access to programmability maybe is a little bit, if you're plugging in a USB all the time, it's not what you want your users to do if they're end users, but if it's a development platform, who cares?
Yeah, I guess I should talk offline with Helmut Lord about that. We don't see that a lot. So
yeah, I think definitely the developer board kind of space for sure. Like, debugger. Yeah. If you can fit a debugger, better than just a USB to serial, but for sure. So yeah,
I would have no idea if there was a debugger on the board. It's all just QFNs and resistors.
Just a little plastic blob, huh?
That's it.
Polyamide thingy dingy.
Well,
Yep.
kudos on the the boundaries and everything. I mentioned this to Ben
That is really cool.
Key, and he was like, "That's really slick." That everything's it's like a little Benno box.
Yeah,
we always
bento
like
box,
to
I like
say
it.
we
Yeah.
always like to say that if we see silkscreen done well, we know the job's going to go smooth, because it's sort of like the canary in the coal mine. Like, but the opposite, it's like a signal that tells us this engineer paid attention to what they were doing, and they've thought about things. There's thought that's gone into this. So whenever we see that kind of bento box kind of thing, we're always like, oh, this is going to go great.
That's nice. That's I like that. That's makes me feel good about the time I spent on it. But really, it was an educate because it was meant to be educational. That's the real thought there. I think we should wrap this up for now. But this has been interesting, kind of starter on this project. What I'm probably going to do, probably offline, because I'm actually kind of a zombie when I start ripping stuff traces, anyways. I'll kind of take some feedback you guys have had. Helmet in the chat, Keenan, Clubman, other people who've stopped by. Really appreciate all that, because this is something that was on my list to start doing anyways, and I think that we can start to dial in something that's useful for Worthington, for Blue Clover, for other people as well, and make it extensible with things like micro headers and quick /stemma headers as well.
You didn't really highlight the Oshawa logo, but they know about this as well, and that's what's cool about this, is that it'll be open source and everybody will, multiple people can make it and change it if they want to, and so that's kind of the point of the whole thing. But maybe it could have been left unsaid, but I just think that's what's.
Well, I actually never got the original Elixir is not certified. It's not a certified sort of thing, so I didn't go through that process. But it is, everything's online, everything's on GitHub, so definitely, and it's permissively licensed. It's CERN v2, the most permissive license that is existing for hardware as far as we saw. So take it, and the only thing you're not allowed to use is the little Golioth logo. That's the only one. Can't use that on other boards.
It's such a cute logo, though.
Yeah, thanks. All right. Well, thanks, guys. I will follow up, and hopefully we'll do another hardware stream here soon. Where can people find your stuff online so that they can check stuff out as well?
We're at bcdevices.com.
Okay, great.
And we're worthingtonassembly.com. It's the best place to start.
Okay. All right. Thanks, guys. Thanks for being here, and thanks for taking a look at Golioth hardware and checking everything out. And we'll hopefully be making some interesting connected hardware and testing it, taking all the way through through the line soon. Have a great day.
Thanks, Chris. Thanks, Pete.
Yeah, thanks, guys.